just gotta let me know. Great. And we're good. Right.
Let's see. So
Take your time, have fun. It's only unlisted today, so don't worry.
we'll see. Okay. Hello? Can you hear me?
Yeah.
Where are the people? Just 0 viewers at the moment. Yeah, there's no one.
Yeah, no one watching yet.
No one at the moment joined. All right. Did you share the link then to this?
Maybe we put the link in the chat.
Okay, so it's just me and you at the moment. So is there anything particular you want to?
PDF one. He's got the PDF one.
Yeah, that's good. PDF.
It's not really particular. I didn't really struggle that much with these.
So
It's just a lot of question there. Isn't that didn't fit here.
yeah, just jump into the things you just covered the things you want to particularly look at.
In this paper, I only didn't do 2 questions. The ones I didn't do, I didn't do 2A.
2A. This on the parity check.
Yeah,
Okay.
I don't know what parity check is really.
Have you done the 2B?
Yeah, I've done 2B.
Okay. Yeah, that's kind of explaining the things you did in the second 2B. So the idea of a parity check is that basically you decide you want to send, let's say, a byte, 7 bits.
Yeah.
And you decide if you want you add an extra bit. That's parity check. That makes sure that the sum of the bits to 1 are odd or even.
Okay.
Let's say we decide it's even, and you make sure that you add the parity check to 0 to 1, so that the sum is. Let me try to write something down here. So it's pretty much describing what's on the other part of the exercise. So let's say you have here in this case, you probably spotted that they decide to do odd as a number of 1s. So the first column is 3 1s, the second one is 4 1s, and then the parity bit is set to 1, so that the total number of 1s is odd. So the way to do the parity check, if you only send a single byte with a bit, you are able to detect if an error occurs, but not to know where it is.
Okay.
Because you only know that the number of bits is not odd or even, but you don't really know which one. But if you build a matrix like that, then you can basically do the check on columns, the check on rows, and then you can find the intersection there. If the number of bits is not odd or even based on what you decided, so you can identify the bit. So that's the whole idea. It's just a kind of putting in words. Oops, just putting in words this touch. No, it's not. Putting in words the other thing there. So here is saying, not to identify, it's only to detect. So you don't need to explain the matrix. You need to explain just how a parity check works. So this is this: when you take your bits, you count them. Let's say we decided they need to be odd. If they are even, you add a 1, and then you transmit them. When you receive them, you basically do the count of the number of bits. If that is not odd or even, there is an error. You don't know where, but there's an error. Yeah. Sorry, bear with me. I'm trying to understand this piece of stuff. But it's just a mouse.
Yeah, we need to click on the pen, that one.
Oop.
It's a bit hard to get the hang of.
Yeah, I'm just testing a bit how to delete this.
It's all next to it.
There we go. Cool. Right, so Is that all right? I think if you manage to solve the 2b,
Yeah.
I'm sure you understand the A.
I can really get the wording a little bit.
Yeah, the wording can be a bit. So I think you don't need to specify anything about the metrics. You just need to say about how a parity bit works and how what the receiver need to do in order to check. Right. So what's the other one? Oh, no.
Is it, wait, I've got one in the end, but can we go over 3 as well? So 3, I'm not 100% sure on question 3. I sort of get it, but not fully.
Okay. Yeah. So all of them.
Yes.
Okay. Let's start from this one. So the paper is asking, write on the diagram to explain the instruction shown and show the contents of the accumulator after the execution of the instruction. So what LDD is described above. Oh, come on. Yeah. So LDD is load using direct addressing. Do you know about direct addressing? Yeah. So you specify the address, it's automatically looking to the location.
So it's just rewriting what's
it's not actually writing, it's a read operation. So it's looking at, so this is the address 105 is looking at 105 in memory. So this, oops. So this is the address. So basically looking to the memory at that specific address and load the value into the accumulator. So you go to write on that. Not what I wanted to do. So this will be, exactly the content, right? Sorry, that's not really working. Apologize. It's going to do it 0 here. Let's see. 0, 0, 0, 1, 0, 0, 0, 1. Okay?
Yeah.
Right. Then moving down. Okay, while this is different. This is the LDX, is the index addressing. So what happens here in this case?
I'm not too sure.
So the first thing, so the second part of the instruction is still an address, right? So but instead of looking directly into memory, you need to first look at the index register. All right, you need to be very close to it. So you need to look at the index registry. What's the value that's in the index registry in decimal in memory? That's 3. All right. So what you do, you take 101 and you add 3.
Okay.
1, 2, 3. So basically, the address that you need to look at is the sum of the address in the instruction plus the index registry. So you look at the location 104, and then you copy the value into the accumulator.
Okay.
In this case, so it will be basically that one.
Yeah.
Okay. Right. So this one is the one to copy, and this will be 0, 1, 0, 1, 1, 1, 0, 1. Make sense?
Yeah, that does it.
It's quite useful because you can change the index registry as you want, and then you can access different values. If you're familiar with arrays, like when the arrays, you can just, the way that they work is actually like that. The index you provide is the location of the array, of the element of the array. So let's have a look at the next question. Okay, so this is actually a program. So we want to trace this program and see what happens, basically. So the first instruction, what does it do? So this is the same as the exercise we did before.
507 into the accumulator.
Okay, so what will be copied?
22.
Exactly. Okay. Try to keep it that visible. So 22 will be copied there. I just realized probably a test box is going to be easier. Is that? Not that one. 22. not here on next line. You know how about the trace table, how the trace table works. So you just say the values of each element, location on the memory and the location of the accumulator over time. The more each row is basically the nest instruction. So I want to be able to see the whole code. So the nest instruction is inc. What it does.
Contents of the accumulator.
So what would be?
So it'll be 22 plus 1.
Okay, so the next value of the accumulator will be
23.
perfect. That's that. So the next instruction is store 509. What it does based on the description. The good things about this is you have the description of the instruction.
All the contents that they give you first, that's just 0.
So it's copying what's changing in the table here. Need to go down a bit here just to add. Cool. So what's changing here? So you store the value in the accumulator in the location 509.
Yeah.
So what's going to be stored here?
0.
You sure?
509 is 0.
So let's go back and look at the description of store. Where is it? Store the content of the accumulator at the given address.
So it'll be 23.
Exactly. So
Oh, okay, yeah.
copy the accumulator into the location 509.
Oh, okay.
Make sense?
Yeah.
The next instruction is loading again from 508 into the accumulator. So accumulator will become
58 is 170.
one. What's the value in 508?
170.
17. Where the two come from?
170. It's 170.
Oh, okay. Cool. Perfect. Then you do another inc.
Add 1, so it's 171.
171. One. Then there is another line missing there, but we then we do store in 2000 in 5010. We can do it the same line.
Store the content of the accumulator, which is 171.
171 in here. That makes sense.
Yeah.
And then there is end of basically stop actually running any instructions. Cool. Something else on this 3 or is this the last one? Okay, it's the last one.
I can do 5B and 5 CIE.
5.
So I wasn't sure how to work out the height and width.
Okay. Okay, so you did that.
I don't know how to do it.
Converting the number in binary.
Oh, okay.
So okay, let me have a look at the test just to remind myself. So you have 3 locations of memory. So the exercise B say the number in location 151 and 152 are the 8th and the within pixel of bitmap graph is in my memory. What are the dimensions? So what you need to do is look at the location of the values 151 and 153.
Turn them to normal numbers.
This one.
Oh, okay.
So basically, so the number 151 and 152 are the address of allocation in memory. So the values is you basically need to convert into decimal these two binary values.
Okay.
Do you know how to convert this into decimals? Excuse me.
I think that's 205.
facilitator.
156. So 205. And
Fantastic. You know this stuff already. That's great. Yeah. And hey, width is what's this binary value here?
156.
Awesome. That's brilliant. So what did you didn't get from the question?
I don't think I read the question properly on where to get the values from.
The actual value, yeah.
Yeah, I didn't read it properly.
So I think the tricky bit that could sometimes get confused as well. Like the first one is what's the binary value for the address 150? It's not asking the binary value of the content, but actually 150.
Yeah.
Like when you say content of the address.
People will look at that.
Yeah.
Like that, yeah.
Yeah, it's very easy to make that mistake. Well, the second one, you're asking actually the content of the address 152, that is not 152, it's actually the thing, the content. So yeah.
It was CIE. It's like lossless and lossy. This one. CIE.
This one. Okay, right.
Hello.
Hi, nice to see you.
Nice to see you.
Have a good evening.
Good
What did you do tonight?
Sorry?
What did you do? Physics?
Physics.
Awesome. So let's do
I don't really
that.
know about lossless and lossy techniques. I've not been taught them. That's why I don't really get it.
You said you're familiar with them.
And I've no,
Okay.
I have no idea.
So the whole idea is, so let's say you have a big image,
Yeah.
right? That's 10 megabytes.
Mhm.
If you, the goal of compression is obviously make sure that the file is smaller in size. The lossless compression means that even if you compress the file, you're still able to come back to the original file as it was. Let's say the beginning is 10 megabytes. You maybe to reduce it to 7 megabytes, but you are able to come back like zip. If you do a zip of the image, for example, you will be able to come back to the actual exactly the same original image.
Yeah.
While lossy is you actually reduce the size of the image and also you are not able to come back.
Oh, okay.
So the advantage is that you can compress significantly.
Yeah.
If you have a bitmap, if you use the JPEG is you lose some data. It will be a lot smaller. You will be able to send it via emails much more easily, but you won't be able to get the full resolution back. Make sense?
Yeah.
There are some algorithms that are explained as part of the curriculum that's to learn, like the run length encoding is one of the classic lossless algorithms. So the idea is that let's say you have a bitmap, a big image with only a square in the middle, and all the rest is white. So basically, you could. The idea is that instead of having 1 million white, you say white 1 million.
Okay.
Because they are all the same, right? So you can just compress significantly. So that's one technique, for example. Make sense? I think that's what they're looking for, to explain this difference.
Oh, okay.
Also, is there anything else in this paper?
No,
You want to move to
no,
do some programming?
I'm fine, everything else.
You want to move to the other paper?
Yeah, sure.
I just want to make sure that
Yeah.
I cover what you need most,
Yeah.
rather than
This is what I did today. I'm not sure if I had any problems with this. I didn't write any program code out, so I actually.
we can look at some. I brought some. I can send you a link later. Oops, no.
No, it was just a program. I didn't really struggle with this one. It was just a program code I actually really write out. I knew what I had to do for it. I just didn't write a program code out because it was just really long. I knew what I had to do. I just didn't.
Yeah.
Like, it would took so long to do.
I think it's the most important things to do. Yeah.
I prefer doing it on a computer. So you can
Yeah, on a
see it as
computer.
well.
Yeah, it's better to do it.
So just writing it down, I don't really like it as much. I prefer doing it on a computer.
Yeah, I think it's the best thing to do is to just practice on a computer until you become very comfortable to write on paper. Obviously, you need to do that at the exam.
Yeah.
But yeah, it's best starting with a computer. Do you have an environment like Python? And you
Yeah, I use
use
Python.
Python. Yeah, because I assume that's
Like
Python's
me
the
and
most used.
Nils, we're making our own app. Like we're writing a programming our own app, just me and Nils. We're starting that, so
It's
we
mobile app.
yeah, it's better to program it on the computer than writing it down, so we
Oh,
don't benefit from that.
That's cool. That's very cool. Okay, so what do we want to look at?
I'm not too sure because I don't really struggle with this paper. Like, I'm not sure if anyone like watching it would need help, but I don't really struggle. I don't understand it all. I don't struggle with any of this.
I'm gonna check if there's no one here.
Oh, okay. Yeah, I didn't struggle with any of this.
So we can maybe try to do some live coding if you want. I don't know. So let's pick one of these exercises here. Which one is the one that you think is the most interesting that we might tackle? Like I think the one with the menu is probably the most interesting. Oh.
This one is discounts.
What are discounts?
I'll probably say this one.
Yeah.
This is just the display menu and stuff. That looks the most interesting, like hardest of the three, I think. So looks the hardest. It's
the last one, is it? Yeah.
This one. It's not this. 2C. No, 2D.
2C.
2D.
Oh, 2D. There we go. Yeah, I think that was the most interesting, is it? Okay. It's going to be tricky to write the code directly on the PDF. So I'm interested about the thinking here. So we have already a lot of, so this is kind of rely on the previous steps that we built. So what we want to do here, the goal is basically you want to show the menu with 4 options, right? You want to show this menu constantly, basically infinitely, and you want to ask for a choice, and you want to give 3 attempts to each choice. If you pick one, you call a function called readFile, right? A procedure. Some of the things that you already have into code, and
pseudocode is similar to Python.
Yeah.
Sort of in a way.
But you need to write some additional code as well, so you can really put things together.
Will you use a loop in this, like a while loop or a for loop, or not really in this one?
Yeah, because what it's saying here is the program will repeatedly display the menu and respond to the user choice. So
a for loop for this. I think
you need to have 2 loops, 2 nested loops. So one is the one actually inside the code written before that does the problem that Python doesn't have, as far as I know, repeat until. I need to convert this into a while loop. So you need to kind of change this condition. So the first things that I would do is create the procedure. Yeah, so it's relatively simple to do, so that you can actually create. Let's try to write some Python here. Text. Let's see how to do that. Right. So display menu. What would you write here? Actually capitalizing them. Menu. So you want a function that display the menu.
happening on this computer?
I've got my ID in my computer, but
Oh, okay. It's hard to show it.
it's we need to find a way to do this. We could find an editor online or something, but yeah. So the best things, yeah, I probably best things is to show you the code that I brought online because it's so I put up. Can I open a website? Yes or no? Or it's gonna screw up.
Chrome, I think it might still carry on, I think.
So I can open another one.
Hopefully.
So a repository where I'm intending to put code as we go on the papers. There we go. This one. I'll send you a link on Slack. So that's what I wrote. So this is the actual paper. So the menu here, things code is this one. That's the one I wrote. So the display menu. So it's printed a menu with the 4 options, and the text is basically what was in the paper. Read file, just print read file code. So the whole idea is that having a while loop that constantly runs. And if, so this is basically, if you can see in the paper, we have some pseudocode. So the internal part of the algorithms is kind of, as you said, translating pseudocode into Python. It's kind of testing that.
Yeah.
So you see that I'm still calling this I because it's what they want. So I equals 3, display the menu, number of attempts is 0, choice it's 0. So the interesting bit is that there is no until repeat in Python. So you need to convert the logical expression here so that it's kind of inverting. Here is until choice is greater than 1 and less than equal to 4, or number of attempts is I. So we need to invert this if you want to put in the while. So I want to stay inside the while until, so if choice is less than 1 or choice is greater than 4, so it's invalid, you want to stay. And the number of attempts is less than I. If it becomes high, I want to stop. So then we get the input, the choice, and number of attempts is increased by 1. This is exactly, except the logical expression is exactly the translation of the pseudocode into Python. Then you do the if that you actually did in pseudocode as well. The call read file, then the print add customer code, the search, and the search customer code, and if choice is 4, will actually exit the program. So that's how I implemented it. There might be other ways, but what they're looking for is you write in the display menu with the for entry, you write the read file function, you write a indefinite loop, you actually do another nested loop that actually does the number of attempts right, you do the values if for the choices. So they are kind of looking to those things. Doesn't really matter the name of the variables you give, except I think the one that are the same as in the paper. So yeah, that's basically the code I wrote. Any question that makes sense? Or,
Yeah, it makes sense to me. Yeah.
So of course I'm not able to run it here.
Yeah,
but
it's quite a simple code. You think about it in this paper. It's not too complex. They give you most of it there.
Yeah, most is there. It's just kind of
It's
I think it's kind of mostly testing if you understand the requirements, that you know exactly what it's asking, rather than you coming up with new code. In this case, and the syntax of your language of choices. Awesome. We can look at the other problems if you wish.
We look at discount one as well.
So the discount one, I think the one I probably need to do some changes and just. So the discount one is the last one, is it?
Yeah, last one.
So probably. So I created a file, discountdates.txt. So as basically identical to the paper, what's included in the paper, with some dates and true if there's a discount or false or not for that particular date. And the discount dates, what it does is taking a date as a string and open the file in read mode. So what we want to do is to, given a date, we want to look into the file line by line, see if the date is there, and if
We don't
this
have to be edited or anything like that. So we can
yeah,
read.
exactly. It's completely only read only.
Yeah.
And then we can just do that for line in file to read line by line. We split, we'll get the first and the second. The first one is the date and the second is the discount. And then if the search date match, so discount is true, I print this discount rate date. If not, I print no discount on this date.
Okay.
So I implemented this way, but I think I probably need to close before the exit, and also here I need to do the close file. I haven't done. There's another way of doing it in Python that doesn't require to do the close file. I think it's we need to do with something like that. So I think probably we'll change that later on. But yeah, there are different ways to implement it. So one way is you can have a variable like record found, date found, and then when you are inside this if, you set that to true so that you found it, and at the end, if you found is false, you print that. Otherwise, no. You can do something as well like that instead of exiting. But I believe it's not needed for the A level, but there's no point to carry on looking at the file if you found the result.
I get that.
If you you could implement it in different ways. That's how I did it. I think this is very useful for you to actually do it yourself. So you can look next time, so we can compare the two things. Okay. So this is the code. What's up the other one? Let's have a look at all the other ones. So the marathon one, this was mostly the algorithmic one. So what it's asking is
1.B2.
1.B2. There we go. So yeah, you want to have hour, minutes, and seconds of your time. You want to know the best marathon time. You want to compare if it's better or not, or equals. So you might assume how would you go converting the hour, minutes, and seconds in all seconds?
So you know what they enter their time. You convert it into seconds.
Yeah, you enter three values: hour, minutes, and seconds.
And then you make it all into seconds.
Yeah.
And you compare it to the.
And then you also enter the best time.
Yeah, to the best time, and you compare them. If it's better than the best time, you'll print something. If it's worse, you'll print something else.
Yeah. How do you calculate the total seconds?
If it's from minutes, you divide it by 60. I think to get seconds.
You divide.
If from minutes to seconds, you divide it by 60.
So what we have, let's say you have. Let's go back here. Let's say you have. What's that?
Don't know why it's not working.
Yeah. Oh. So I should. No. It's so let's say you have it's not going to pick this. You have 1 hour, 2 minutes. Oops. 2 minutes. Oops. 1 hour, 2 minutes, and say 30 seconds.
Yeah.
Right. What's total seconds? What's the expression would you use for that? See. So how many seconds is 1 hour?
I'm not too sure. How many?
Can you calculate that? So how many?
So it's 3 divided by.
How many seconds as a minute?
How many seconds in a minute? 60.
60. So how many seconds in 2 minutes?
120.
Yeah, that's 2 by 60, is it?
Yeah.
Why in an hour? How many minutes there are?
60. So it's 60 times 60.
Exactly. So you sum all those.
So 3,600.
Right. Whatever it is.
Okay.
Okay. So the idea is that you can do it in different ways. You can just do
So 3,750 seconds.
3,000.
750.
Yeah, trust you. Then so I'll show you the code basically, but it's basically doing that. So marathon. So you get race hours, race minutes, and race seconds. Personal best as well. So that's the expression I wrote.
Okay.
Can you rationalize that?
Okay, I understand that.
Excuse me. So race seconds plus basically 60 seconds per the total number of minutes.
Yeah.
The total number of minutes is race minutes plus 60 minutes per hour.
Yeah.
Right? It's a very efficient way of doing that. If you have a lot of this multiplication, you can do that. And then you take you print the race time in seconds, and then you do the if to check if it's below less or greater than the personal best. So those are the problems that actually they ask you to write. Okay. Okay.
That's the last one.
Hmm?
That's the last one of these.
Which one you wanna?
There's no more.
No more. These are the three, right?
Yeah.
Yeah, there are other exercises here. Have you managed to do the others here?
Yeah, I did every other question. Yeah.
Okay. So what do you want me to cover?
I'm not sure.
So
It's not
yeah,
really fun, everything
I'm not
else.
sure if other people want to maybe look at later. We can actually have a quick scan of all the questions. Start with the second paper here. So so the first exercise was actually, so you have this algorithm that ask you what are the variables that you need to write these algorithms, right?
Yeah.
So as we've seen before, you need the hours, the minutes, the seconds,
And the time.
and the actual overall time.
Yeah. And that's really simple.
Yeah. Then so this is the one we actually seen. So I think the best way of doing it is you write the code first, then you come back to this exercise to put the identifiers that you needed.
Yeah.
So it can be quite difficult to think about all the identifiers before you write the code. So okay, whiteboard texting. Whiteboard texting. What's
So with whiteboard text, it's about test every possible path through the code, every single possible way it could go, and like while knowing the code, like with knowledge.
correct? That's brilliant. And that's different of the other one that's called black box texting. That instead is what is the
I'm not too sure what black box is.
the only idea is that you kind of you don't look at the code at all. You know what's the input and output of the program is, and you make sure that the requirements are satisfied. Let's say you know that you have hour, minute, and seconds, and you want the output is the total seconds. I don't know how the program is actually done. I just want to measure the input and the output. Then the V2 is, so what's actually asking here to complete the table. It's kind of asking you to do some test cases, is it?
You can basically input the values, any values yourself. You can make them up, so that you can calculate the seconds.
Yeah, but you need to, as you said, you need to basically cover all the possible
So you do one above, one below the overall time. So the first one is equal to the personal time.
Exactly.
The second one will be better than, and the third one will be like less than.
Yeah, exactly. You need to basically come up with some number that provides all the different.
I did one above, one below the personal time. It's just simpler than working out brand.
Yeah, I just did the same. Right, you just do 12 seconds.
Yeah,
1:15 is it? Yeah, 14. Yeah, exactly. That's clever. I did exactly the same when I tried to do the test on my own. But yeah, you can put any numbers as far as they are more than. The spine for testing, of course. Obviously, if you want to do comprehensive testing, you definitely want to
Yeah.
change the rates and the hours and the minutes and the not only seconds. You want to change all the variables as well. So okay, so this one was actually asking for what this is doing. So this pseudocode here. So we just covered with the program. So show the menu and then ask for a choice, input the choice, and repeat until the choice. So repeat indefinitely until the choice is valid. So valid means is between 1 and 4, 1, 2, 3, or 4. So the loop is required to avoid,
To validate it.
to validate the input. Perfect. Then is adding something there, the number of attempts and the constant I. What this does, what's the maximum number of inputs the user could be prompted to make?
3.
That's 3. Correct. You know why is 3?
So I set to 3, which is a constant. So any more than 3, it's not equal to I anymore, which makes it not true, the statement not true.
And what if the number of attempts was set to 1?
Then it would be 2.
So it's very important that the number of attempts is, you set it to 0. It's very easy to make a mistake with it. Just do one more or less. But the repeat until is it's just making sure that you just try 3 times. And so why this is an improvement?
It limits the number of attempts that you can do instead of making it unlimited. So if it's unlimited, easily, like someone's trying to hack into it, they can just run every possible combination. If you've got only 3 attempts, they've only got 3 guesses, and if you can't guess it in those 3, you're locked out.
Yeah, it's not quite a login, right? It's not a login system.
Closed it.
It's just a way to reduce the number of attempts.
I think it's like a security sort of check. That's what I sort of thought of it.
Yeah, even if you look at the solution has been asked to do afterward, it's a bit interesting because it's still kind of doing a while loop at the end, right? So it's not really that difference if you actually do this. But if the program terminates, like you say, after 3 invalid attempts, you finish. So the reason is just that. So this is the code that's been. So do you have some code? What is asking here? You need to.
Numbers.
So it's
pretty simple.
Yeah, it's just the
part if choice equals 1, it's
using pseudocode. Yeah.
You just use each possible combination.
Okay, so it's the code that we wrote. Right. So how did you find the modular design thing?
It's hard to explain, but I wrote it all out.
Yeah. So
I'll choose these.
Yeah. So you need to choose. Smaller. Yeah. What's the mental way of thinking here? So the first question is asking to actually fill the boxes.
Yeah. So it's the big ones. And you read them, just sort of like smash them up. So what they could be.
So you have access premium rates database, and that's you get premium rates. So what's need premium rates? Definitely calculating is it the price.
Yeah.
No.
Sure, it's quite.
Okay, so if it's fine. You don't want me to cover that? It's fine. Then the other one is, this is kind of completing code, is it?
Fill in the boxes. That's quite easy.
Okay. I'm struggling a bit with the technology at the moment. Um, so how did you do
So
that?
for
Just do a for loop 1 to 20. Then you get a player 2. If the player 1 throw is greater than player 2 throw, you just increase player 1 total.
you end for loop.
And if you completed the for loop. Yeah. You should write this down, but I'm struggling here.
Yeah. I'm not sure why it's not working. It's always a bit like this. Let's not just try and work.
So, you've used Potter when it's actually producing correct result.
It's when they're both equal. Player 1 total, player 2 total are the same.
What do you get as an output?
It's like no winner. So it's
What's the incorrect output when they are the two totals are equal?
this one is no. I think there's no output. I don't think. If they're both the same, there's no output.
What makes you say that?
In the code, it doesn't. There's no possibility if they're both the same.
So let's say we have player 1 total is 10 and player 2 total is 10, right?
Yeah.
So we do this
It's not greater than or less than.
If it's,
Oh yeah. So if this one, it will output player 2 is the winner.
exactly. So the condition is false, and then but the else will actually be executed.
Okay,
so we'll print player 2 is the winner,
If
despite
it's
this.
not, yeah.
If it's not.
Okay.
So that's important to say. And okay, what's next? Oh, the sales website.
Yeah.
Your CLX is one. Let me know when if you want to take a break or anything like that.
I think this is like, I get all of it, so it's not really a problem for me.
Maybe the structure to be using. Okay, so you got this all.
Yeah.
So I wonder if we should something different. Or,
You can ask Tom.
yeah.
I'm not sure if there's anything else. I've gone through all the other papers.
Yeah, I can easily make up some programming things to do. Trace the execution of this process of the code. So you've done the tracing here.
Yeah.
That's good. Yeah, of course you've already already how to code that, right? That's easy for you. It's not really the first week, is it?
No. Oh, I'm using it as
Yeah, but yeah. Not this side. Okay. You got those. Also open file here for your desktop as well.
You open it for writing, you then put the next day, discount, next line equals concat.
Yeah, absolutely right. And then it's done. Do you want to ask Tom one more? It's like you kind of got it, so
Yeah, I'll ask if there's anything else for us to do.
I'm happy to do any programming or anything.
There's nothing specific they have to do, so they should do whatever, really.
Okay, so tell me a bit about you, about your. I don't know if should we stop the live streaming here? Or,
No, we could, yeah.
I don't know what's best. We can leave it there. I don't.
Okay.
So yeah, tell me a bit about you, how you, what's your experience with programming? You said you're doing an app.
Yeah, we're making it on Xcode.
Okay, is that for iPhone?
Yeah, we're making it happen, yeah. It's basically like the way we work in the school where we use different things like things called POMs, which are like a shorter like work period.
Pomodoro.
Yeah.
Yep.
We make them all inside an app, so it's easy for access. Like we do like 3 wins in a day, putting that into the app, like making a database of that. Like you can calculate, like keep track of them, sort of do like daily challenges, stuff like that. We do like lateral thinking problems. There's a point system for that. So you get points for doing it. Like you can buy points in our store.
Interesting.
Stuff like that.
Cool.
Just trying to make it so like stuff's easier.
Wow. Yeah, that's definitely beyond the computing. It's a lot.
Yeah.
Easier.
We've only just got Xcode today. We've only just started looking at
We
it.
just started.
Because we don't have any Macs on our own. We're using the school's Macs.
Yeah. Okay.
So
Yeah, I don't have a Mac too. Yeah.
Yeah.
You're using Swift, are you?
Yeah.
It's new language.
I literally today we've only just downloaded it on this laptop today, so we've not really had a chance to try and program
Oh,
it.
right, okay.
We've all planned out everything we want to do.
Interesting. Yeah. And before that, what's your experience with programming? It looks like you
I've done a lot in
already
my
know.
last school. I did a lot of Python, like actually making like programs, stuff like that.
Experience, yeah, it would be a lot easier for you
Yeah.
to go on this
I have a lot of
class.
experience with Python.
Yeah.
We did a lot of HTML as well and JavaScript, like making websites. We did a lot of that as well in my school. So it's stuff I should learn.
Yeah, I guess the challenge for you is now is not get bored.
Yeah.
I guess so. It's of course for the exam you need to be disciplined in writing the code down and
Because making apps is way more interesting than this.
yeah.
Trying to keep focused on the actual exam technique.
So I guess that's in this case if you're already experienced with Python, I think you're already at the point where you can write it on paper directly.
Yeah.
Because if you're completely new to programming, you need to practice on the computer. But
I might start to practice that a bit more.
Yeah,
because I'm just used to it.
if you feel already that you kind of have experience with Python and you can start to write it down and then afterward copy that into the program and see if it runs.
Yeah.
And say, oh no, I forgot that. I forgot the D. And it's gonna be quite tricky, but it's required for the exam to get. I don't know. Yeah, that's definitely what I would recommend. Because most of the paper 2 is actually exercise, actually code, right? So that's definitely. Do you want to take a quick break? Like we spend an hour and a half already.
Sure. When do you want me to come back down? Do you want me to come back down at 7? It's 8 minutes.
And whatever you think you need.
Oh, I'll do it at 7.
Yeah. Awesome. Take some water. Do you know?
Yeah.
Should I stop the? I leave it running.
Yeah, we're about to go live again. Right. Apologies for that. So I say, I mean, I've already agreed for you to be here till 8. So
Yeah.
if you want to do something useful, then
Yeah,
great.
I have some ideas, but
Okay.
can we stop that one and
Of course.
and
You don't need to.
I can do some programming, I guess.
I'm sorry, I'm just
Thank you. So
of course.
he's really quite
Is he
efficient.
Is he?
So it's obviously
He loves it. So
really far ahead.
good.
That's
That's
the, so it's great. So it really doesn't need to cover it. And challenging with more exercises. Yeah.
Put them on the A2s. Right. If you don't want to, don't be lazy.